Euler's, where is the only place that we have an equals and only an equals? The initial point, like a tangent line, it only shares in one guaranteed point. It could be somewhere else, but forget that. One guaranteed point. True? Okay. 1 equals. What do we have to do past that point? We have a few options, but this function value eventually is going to only be approximated by whatever Euler's gives us. True? Do we remember the big picture of Euler's? It's a tangent line. What do we do with the tangent line? We break it and we make a new tangent line, and then we make a new tangent line. As we're making new tangent lines, we're trying to follow the curve. How far out do we go before we break and start again? That's our step. That's our h. That's our delta x. On the FRQ, I believe it was 2. Because it was h of 0, h of 2, h of 4. Anyway, coming back. So that's our step. Step go in our actual equation. Multiply by the differential equation. What is this? This is a y2 equals a y1 plus an m times an x minus x1. This is a tangent line. This is an L of x. That's approximating a function value. It's my y2 being approximated by my y1. Okay, fine. It's my y being approximated by my initial or my previous plus a derivative, a slope, times a change in, times an h. Right? So how do we find this? Slope. How do we find slope? A differential equation. True? That's Euler's. And we go however many steps they want, and we try to follow whatever directions they give us. Sometimes they give us the step and the function. Sometimes they give us start here, end here, and this many jumps, and then you have to figure out the step yourself. But in some way, shape, or form, they have to give you a differential equation or some clue about the derivative or the slope. Okay? That's Euler's, but what else was the packet on? Logistic. People who took the AP on Wednesday. Was there something that you had a question about with logistic? Yes, I think it was multiple choice though, right? Multiple choice. Something they got stuck had to come to the differential equation. Could you be asked to deal with the differential equation of logistic growth? Yes. Could you be asked to deal with the actual general solution, the original, the population? Yes. Could you be asked about the carrying capacity, which I heard was in class, but whatever, that constancy thing, right? AP Bio shout out. But could you be asked for the fastest? Yes. The fastest happens at half the carrying capacity, but pause. What kind of quantity is that? Is that a time? Is that a when? Or is that a how much? It's the population. So when I cut the carrying capacity, which is what the total population, that carrying capacity, that total population, as to how many could be infected or how many this or how many that, whatever limit is, whatever that constant is, I cut that in half. Still a y value. If I want the when, what do we have to do? Back to Taylor series in a second. So, LTF number 2, the one that's due today. What's actually due? Just the odds. True? Oh, sorry, it's the weird awkward packet where they only copied half of it. Ugh, so annoying. I know, don't think about it. I was really sad. But that's okay. Next week we need things to do. So we'll have the second half of LTF number 2, and then we'll have LTF number 3. Because in Calc AB, let's be honest, you had how many? 12. Wait a minute. I said this yesterday verbally, but let's go ahead and look at it all together. Where am I right now? Shared folder, class resources, Google Classroom. Where am I now? AP Exam Prep. Where am I now? There's the 1, the 2, and the 3, the nice full versions. I apologize. I don't know what happened. But what do you see right here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All the ones you want. Oh, thanks for that face, James Galvin. Yep. It's a little overwhelming, but it could also be helpful. Some of you are like, I already have mine from last year. And you're still weak on things. So maybe you should print off a blank one and try again. Now pause. Am I requiring any of this? But what am I trying to do? Make it available for resources. Is that cool? Yes, but I'm not going to split up evens and odds. It's going to have to be the entire packet. My advice would be to print it like I print it here with like the double and back to back to save on paper. And I'll only make it half the bonus just because, come on, a full-length practice AP exam should not be worth the same as an LTF packet.
So those would be 2.5
So it'd be 2 points. Because the bonus practice exams are 4 test points. So only be 2 points. Man, I'm giving you way too many opportunities for bonus, but there's no way I shouldn't say that. Anyway, I'm just going to keep going and pretend like none of you are actually going to do that, because if you do, I'm a horrible teacher and we should sue. Don't. Okay, LTF number 2. Oh, there's one more thing I need to go over. Okay, pause, last thing. Why do I just have my Smart Notebook randomly open, and I want to show you something about my random Smart Notebook that's randomly open? Some of you are using my Smartboard. Actually, according to the sign-up, everyone is, but maybe not everyone. Everyone but one. Okay. If you use my Smart Notebook, can I just show you really quickly what I can do as long as you just ask me to have it ready for you like Kathy did yesterday? Cool? Some of you were in here when Kathy was actually taping hers. She did 2018, which was the Saturday Mock AP, AB number 5. Don't worry, Kathy, I won't actually play your video. Although she did great. She did great. Okay. Here's what I had ready for her. Okay, I had to do some copying and pasting. It takes a little bit of time. Just be like, hey, can you get like the Kathy thing set up ready for me? Sweet. If you want that, all I need to know is Saturday or Wednesday and the number underneath your sign up if you want to do that. That might be the easiest way so you don't have to talk to me. What I have is the question and A, then I have a space for the blank page, and I have A's scoring guideline. Then I have B, and then I have B's scoring guideline. I have C, and I have C's scoring guideline, D, and then D's scoring guideline. That was like the basic setup. Now, technically, I did have open in Google Chrome. I had the CalcAB forevers, so it's something where she could have gone to the forevers and said, hey, remember? She went ahead and just wrote out like the tangent line, and most of her FRQ didn't really need the forever stuff, but you guys can imagine like sometimes it's helpful to see some of those like increasing, remember, derivative. So I could even have like specific forevers open, or you could open up specific forevers to go reference, etc. Those of you guys with graphing calculator FRQs, I'll see if Mrs. Christensen can get it working for me. If worst comes to worst, we can put up Desmos, or I have a webcam. You can just webcam and you with your little calculator. Hey, look, I'm pushing in the numbers. That works too. So those of you with a calculator FRQ, we might just go webcam it, and that would just be hitting this button, and I'll show you when you're in here. Okay, there's a few other things I wanted to show you really fast. With the screen recorder, anyone who's watching this video, sorry, it's going to get really confusing right now. With the screen recorder, when I give you the microphone and when I say, here you go, let's record. If there's 2 of you working on 2 FRQs, it's up to you whether both of you help on one video and the other video, or whether one does the other. I don't care. You talk it out. But technically, there's no new stamp sheet. I don't mind. You're lucky. Spoiled rotten, but yeah. All right. I'm ready. Logistic Euler's method. For anyone who just realized that being stopped for a long time, I was explaining the screen recorder and the Smart Notebook and what can happen for you to record your A/B FRQ explanation video on with using LTF number 2. I'm ready. Let's go. Maggie.
I understand why option 2 is correct, but I don't get the
There's a lot of notes. Sorry.
Yeah.
Whew. Okay. Number 3.
Yeah. So I chose
Wait, is this from like some earlier something?
Yeah.
Suppose the rate of change, and then we're doing Euler's method. We're doing a step size of 0.2. And and then we go down here, 0.5. Oh, got it. Thank you. The approximation using Euler's method is too big. Okay, this one they're saying it's an over approximate. This one they're saying it's an under approximate.
Check. I got that.
Oh, you got those 2. And then you're wondering why this one?
Yeah, because I chose B.
On the interval, so you realize it wasn't an overestimate. On the interval 1 to 4, f of x equals c e to the x squared. F of x, y equals, which would be exponential. They gave us a differential equation. I'm just going to do it old school, like basic calculus. They gave us a differential equation where dy dx is equal to 2xy. And they're asking, solve the difference. That's what I would do. And pretty quickly you'll get your ln of y. Makes sense.
That's okay.
Yeah. F of x is probably what was throwing you off and making you think it was like a weird, but it's a basic differential. Not basic, sorry. But okay, what else do we got? Yeah. Anything before 13, evens or odds? Okay.
I remember this being something we learned, but I can't remember how we know if it's greater. So this was something we learned, I just don't remember.
Is this based on? Yeah.
Yeah, but
Ooh. KYL minus y. Do we see it? I mean, they do say logistic, don't they? Mm-hmm. No. Oh, they don't? Oh, yeah, there it is, logistic growth. Okay, so I see my ky times L minus y, and then which of the following? Okay, this is having us analyze a logistic growth situation. So I'm going to go ahead and just quickly, that's a constant, that's my population, that's my carrying capacity, that's my population. And so I could go ahead and I don't really see them needing me. I could do lice minus licked, but I don't really see them needing me to do that. Okay.
we did that as well. You have to do that in order to get.
Oh, so you already have the lice minus licked?
Yeah. So I got 400 over 1 plus 8 e to the negative 0.2. So the answer to that one is C. Because you just said
Okay. Okay. So the rate of change, huh? Oh, P. So we're talking about this guy and this guy, right?
Yeah.
And this is just the population, not the rate?
Yeah, that's just the population. And then the other one, we'll take the that's Q.
Right, which is that one. Okay. So the rate of change of P dPdt, which we technically haven't found, but this is a graphing calculator. So we could go ahead and we could actually take P prime. And we could graph the logistic growth and the exponential growth. I think that's what I probably would have done. Where the constant determined by the initial, oh, they told you C is equal to 8, blah, 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 blah. So I probably would have graphed the two and seen what's going on as far as which one's higher, because I literally have the rate and I literally have the rate, and I can actually look at whose y values are greater. That's how I would have thought about those two. Q is changing most quickly. The most quickly. Isn't that fastest? Isn't that at half the carrying capacity? That wouldn't be 400. That would be at 200, right? So that doesn't make sense. That should have been at 200. P and Q have the same rate of change at one time only. I don't know, does it? And then the population model P states that the population increases by 15% per unit time. No. 15% per unit. Hello? That would be 15% per unit time, wouldn't it? And that doesn't seem to make sense. That's, no. That's like a linear growth, 15% every unit time.
There is only one intersection.
And then we're asking for what's true.
Yeah.
So then D would be true. And since there is one intersection point, that means the orientation switches. So neither of those are true because it's not strictly one above either way. The intersection means they switch as far as who's on top. There you go. What else do we have? Evens or odds? Keep going. It's okay. No one else is asking.
The last thing I have.
Pause. Time out. Some of you guys, well, she's not here, like a physics class. If the professor asks for questions, go for it, and you have them ready, right? He won't just stand there all day being like, well, this is boring. I'll make up my own questions. I mean, they can talk about whatever they want to talk about, but you get ready and you have it. And you say, no, professor, this is free time. I don't have to come into your office hours. You're asking me? Sweet. Right? You be ready. Okay. Keep going. I was telling AB that too. Sorry. First, so it's FRQ number 1? Number 2. Got it. KY, L minus Y. Okay, so logistic population of rabbits in a field. Go team. There must be some predators or the grass is going to die because they eat it all. Rabbits eat a lot. Like deer. Like kangaroos in Australia. Go figure. They're actually like vermin. Because yeah. There are some places where there are too many kangaroos. So it's like the overpopulation of deer in the east, or it's like I don't know, where rabbits are ransacking. I don't know. But I know deer and I know kangaroos. Letter C says, as t approaches infinity, what does the rate of change approach? Oh, bummer. I love letter B. It's easy. It's the carrying capacity, right? Because that's the horizontal asymptote. Oh, and then A is talking about, but both of those are the carrying capacity. Both are 1,000, because whether you start below or whether you start above and you're going to go down to the carrying capacity. If like the population ever goes above, then like the predators or the lack of food or whatever is going to bring it back down. Anyway, this is the rate of change. Okay, it's a limit to infinity. Cool kids. I was just reviewing that with CalcBC the other day. That was their LTF number 1. Limits to infinity in general, we're thinking about degree tests, right? What's the struggle of this one? How do I take a limit as with p's? Do my variables match? Don't we know in calculus it's bad when your variables don't match? If you have x bounds with u's or u bounds with x's or y bounds with x's or x bounds with y's, we're in trouble, right? So t p's, well, we have 2 options. One option is go p in terms of t. You could do lice minus lict, and if you did lice minus lict, go ahead and throw in your carrying capacity, throw in your 1 plus c e to the negative l. Hold on. Remember I said this is one option. Then you could go ahead and plug in your, I don't have an initial. How am I supposed to plug in? Part D, I bet they give you a clue. And then you could find the initial and then go back to part C. That's not very AP-ish. But you could from part D and then hope it's the same P, and then you could, and then you could, and then you could go. But does that sound very fun? So what's a better way? I need to figure out the limit as t goes to infinity translates how to a limit as p goes. As t goes to infinity, what were they asking up here? Weren't they asking as t goes to infinity, what's population approaching? What was population approaching? So why don't you change it to be in terms of p, the limit as population goes to 1,000. As you go to your carrying capacity, it's the same thing as the limit as t goes to infinity of your rate of change. Now, is that something I've seen tons on an AP? No. Every now and then? Could you add it to your card? I suppose. You can't go as, but think about it. Is this what you're thinking? Graphically. What's happening, James? Well, that means they're probably not going to give it representation. But did you follow what he said? The graph is leveling off. And as leveling off, the slope is approaching 0, so horizontal asymptote should have known that. Interesting characteristic to bring up. But technically, you could have done it mathematically, or you could have done it graphically and saying, oh yeah, approaching a horizontal asymptote as it goes to the horizontal asymptote. Sorry, approaching a horizontal tangent line as it goes to a horizontal asymptote. Did I write it wrong?
No.
Oh. Good question, though. Yeah.
Could you just go back up to number 3?
Yeah, definitely. Multiple choice? Oh, I'm going to have to do it again. Sorry. But it's okay. I can do it fast. If you guys have LTF number 1, we can go back to table series because some of you were finishing that up. So let's go talk about those questions that you might have seen. Okay. But the long story short was dy over dx, 2xy. I solved my differential equation.
Oh, you can make it y. Okay.
Yeah. 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 Right? They can make it look funny all they want.
I was like, how do you
Yeah. But you guys thought about concavity for the over and under estimate, right? Because the concavity tangent line tells us over or under. Good. I still want to make some sort of forever card out of over under. I just tangent line approximations would be based on the concavity. Riemann sums would be based on the increasing, decreasing. And then we have power series, which is based on, have we even done a power series over or under estimate? A Taylor polynomial? I don't think we have we?
It was on the.
Did we talk about it?
Oh, was that one in the mock? Because there was one where it was like, is a power series.
I feel like they would. I just feel like we haven't seen one yet.
They asked like
Yeah, Justin.
A Taylor polynomial over or under approximate.
Greater than or less than the interval. Oh yeah. That was on our Wednesday mock.
But it was an integral?
Yeah, it was. Oh yeah. Yeah, there was like it gave us to it gave it to us as an integral.
It was like if the it's the integral test and it equals 5, so it converges. But it was like, is the area greater than or less than 5?
Is like the series less than the integral or is it greater than the integral?
Ooh.
I was so
Because the integral was approximating. Okay. When we go over corrections next week, just bring that one up.
Wait, what is it?
So it was the integral to, I'd have to look at it.
I
Sorry.
think it was, I plugged in my calculator and it was over. I think.
So how did you do that?
I just did because it was, I did the integral from 1 to 5 and I did the series from 1 to 5 and the series was bigger. I just assumed that the series was bigger.
So he was hoping like a tangent line that if it's bigger, it's always bigger. Which, I mean, even if you think of Taylor polynomials, when they diverge, like remember how that sign, it was following and then it would fall off? Like, no, but even though it wasn't a tangent line, it's still, if it's below, it's always below, or if it's above, it's always above. But I don't know if that translates to an integral test. I just know I've seen some weird over-under questions that weren't as simple as tangent lines and weren't as simple as Riemann sums. So I was like, that's why I've never made a card over it. But I guess I could make a card for AB and then BC, just add the additional. Sorry, I am just talking, but over-under approximate is, I think, an important topic in general for the AP. But let's go back to Taylor series. When you guys were working on them, was there anything else you wanted me to talk through? Evens, odds, FRQs? Yeah, where do you want me to go? Any multiple choice before FRQs? We have like more than 5 minutes. I'm just like, time, I got it today. No? Really? I'm just giving it out for free. Yeah.
I just have a quick question on 11.
Okay. I'm right here.
Negatives, I ended up getting like, one of them was negative, but the power series doesn't have a negative in it.
You had a negative and it didn't oh, were you doing U prime to be a -1?
Yeah, and that's what.
Really?
So when my first derivative ended up being 2 over 1 minus x to the third. But then my second one was -6, and then when you do over 2 factorial, it becomes 3. But
No, wait. Every derivative, when you bring down a negative power times a -1 will always be a positive, though, right?
But isn't there 3 negatives? Because there's a negative from the first derivative, the negative that you bring down, and then the negative u prime. Can I just...
No. What I mean is there is a negative from the first derivative, but the negative from the u prime made it a positive. And then there's a negative from the power and a negative from the u prime make it a positive. There's a negative from the power, a negative from the u prime make it a positive. You see it?
Yeah.
Every single one will have a negative from the power and a negative from the u prime. Anything else multiple choice? Okay, so FRQs. Which one, Maggie?
number 3, number B, and
Oh, did I just pass it? 3B and C? Okay. Let me steal this real fast. Let me not steal that. Let me go here. Okay. So I'm going to steal your answer from letter A if you don't mind. And then I'll use it for B and C. Okay. Oh no, you took it too fast. Come on. And computers don't move as fast as we do. Just kidding, I know they move faster. It's just me being impatient. Okay. Okay. All right, so what you get for eighth kid? Yeah.
1/2 plus square root of 3x minus 2x squared over 2 factorial minus 4 square root 3 x cubed over 3 factorial.
One more.
8 x to the 4th over 4 factorial.
Okay. If T sub n is the nth degree Taylor polynomial for x. So they just say keep going. Find the coefficient for the x sub 13th term. Okay, so the x sub 13th term is going to be the 13th derivative of about 0, right?
Yeah. You got a point for saying that, and I was kind of confused as to why.
Because some people might just find the derivative. So they're saying, oh, the fact that you knew it's the 13th derivative over the 13 factorial, we get that you understand the formula. Now were you able to apply it? And I gave you the point. Yeah. And then you had two options. Go finding the 13th derivative or find the pattern and then plug in. And the pattern is every other one is going to have a square root of 3. And you're doing 2 squared, 2 cubed. Is that right? Powers of 2? Oh, yeah, because that would have been a negative power of 2. 2 to the negative 1, 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3. Ooh.
So it'll eventually be a positive. Because 2 to the 13.
Yeah, that's what I was seeing. Well, no, not 13. Isn't it going to be 12? Because 2 is to the 1 over 2 factorial. I think it's going to be 2 to the 12 over 13. Isn't it 1 less every time? 2 is squared with the 3. 2 is cubed with the 4. So it'd be 2 to the 12th with the 13th. I mean, with the x to the 13. But the sign. Oh, because it's cosine. So it'd be a negative, negative, then a positive, positive, then negative, negative. So it's every other. So have,
It's going to be a negative, and then when
Thanks.
you plug in your...
I would have literally like counted it out.
I did that.
Yeah, there you go.
Yeah, but it eventually becomes a positive because
Well,
it's sine, it's odd. So it's going to be...
oh, so it is a positive, not a negative?
It eventually becomes positive because sine of negative pi over 3 is a negative 1, a negative 3, square root 3 over 2.
Uh-huh.
So then plus the negative that was in front of it because that's like you take the derivative of cosine, so then it's a negative sign. So then the negative becomes
Oh, it was a negative with a negative, which is positive. Got it. So in your figuring, it became a positive.
Yeah.
Got it. Tracking. See, I would have counted out like positive, positive, negative, negative, positive, positive, negative, negative. Oh, okay. Anyway, go ahead.
In the answer key, they have square root 3, 2 to the 13.
Oh, I forgot about the square root of 3. Sorry, my bad. Every other one is a square root of 3. So the first is a 0 with power. The second, so every odd is going to have a root 3, and so it's x to the 13th. Sorry, I figured everything but that.
And then they have 2 to the 13 as well.
What?
It's because it's sine of pi over 3 is square root 3 over 2. And I think they just like did like that. I don't know what it's called. And
Did they do 2 to the 13th over 2?
Yeah, 2 to the 13th of square root 3. That's what I was good with.
They don't have like another 2 down here? Where it's the 13th degree? Maybe the pattern doesn't hold. I assume the pattern held. Where it was 2 to the 0, 2 to the 1, 2 to the 2 to the 3. No, sorry. 2 to the negative, 2 to the 2, 2 to the 3. I mean, maybe the pattern didn't hold. If I had time, I would have solved the whole thing out. Times 2 times 2. Like I see what in that square root of 3 over 2 with a negative and then cancel to make it a positive. But that should have been chain rule. 2 to the 1, 2 to the 2, 2 to the 3.
That's why I said it.
Chain rule would have been 2 to the 14th. 2 to the 13th, sorry, 2 to the 13th with an over 2, and it should have become 2 to the 12th.
See, that's what I was.
It might be a typo in the answer key. Because 2 to the 12th not only makes sense with the derivative, but it also makes sense with the pattern of the original one. I think the teacher must have made a mistake. It has to be 2 to the 12th. There's nothing else it could be. We could find 13 derivatives and it would still get there, right? Right. But they didn't show the over 2, did they? Or did they?
So this is what they have, and then it just all of a sudden goes to square root.
That's what I was
3
confused
times
about.
2 to 13. That's fine.
Oh, they didn't even plug in the right value because it should have been square root of 3 over 2, and then the 2's would have reduced. Yeah, no, that answer key's messed up. Yeah, yeah, that one's messed up. You guys can go ahead and go. I'm just going to peek at letter C real fast on the video. If Maggie can say it's cool, if not. What are you guys bringing on Monday? And for your board, we'll have time to go over A and B and C. And then if people can't do the whole thing this weekend.
Do you have, I didn't get the number 2 yesterday.
Oh, I should have. What are you guys watching? Is this? Yes.
Thank you.
Does anybody else come?
So, my side,
Okay.
why would I go?
All right, kiddos. So I'm going to go ahead and continue on with part C. Ooh, except I'm totally supposed to be subbing for strike, so I'm going to do it fast. Find an upper bound for, okay, this is totally error in every way, shape, and form. I see the actual function minus the second degree Taylor polynomial. So there's my error. They want an upper bound for error. Use it to find a lower and upper bound for f. So if I can figure out how far off my approximation is, then I can add and subtract and figure out a range for where my actual would be. So that's ultimately what I'm looking for. In order to do that, we're going to need to use the second degree Taylor polynomial. Like we'll actually go up above and we'll plug in 0.2 to that Taylor polynomial, and we'll figure out what that approximate is. Now, they don't want us to actually just plug into f of 0.2 and figure out what that is. That'd be way too easy as far as finding the Taylor and finding the actual and subtracting. So they want an upper bound for. Up above, sadly, I do not see an alternating series, which means that we can't use the alternating series remainder theorem. Which is okay, though, because if we're thinking about this with Lagrange, I would need to, with the second degree Taylor polynomial, look at the third derivative, which I could find pretty quickly, and maybe some of you guys already did, because f prime, f double prime, f triple prime, f prime is equal to negative 2 sine of my blop, and then f double prime is going to equal negative 4 sine of my blop, and then f triple prime is going to equal positive, nope, this is a cosine, positive 8 sine of my 2x minus pi over 3. And if I know that sine itself is always bounded between negative 1 and 1, the f triple prime is going to be bounded between negative 8 and 8, just doing it simply. Ooh, except I'm supposed to be going between 0 and 0.2. If I'm allowed to use my calculator, it makes it a little bit harder. Let me finish my Lagrange down here. So my error is less than or equal to my Lagrange. I'm doing 0.2 from 0 cubed. It depends on how much they want you to use your calculator, because you could maximize the third derivative of z with that simple rational and be like, oh, the max is going to be 8. But technically, if we were doing this with a calculator, we'd be maximizing this guy on 0 to 0.2, which sine is increasing, so therefore, technically that would be 8 sine of 2 times 0.2 minus pi over 3. Stink, it totally depends on, I would normally say just go with the rational because it'd be a non-calculator problem. But they're asking you to use a calculator. So go ahead and check in on Monday as far as how they have you keep going. But I would assume, it's dangerous to assume. Non-calculator would be that. Calculator might be this, because that's truly the max on this interval. I have to go be Mr. Strike, but hopefully that helps just a little bit, and I'll talk to you guys. Catch ya later.